So for section 2.4, we're looking at set operations of Venn diagrams when we're dealing with 3 sets. So in 2.3, we were looking at 2 sets Venn diagrams like this. And in this section, we're going to look at 3 set Venn diagrams that look like this. The first section we're going to look at is just shading different regions to make sure we know which region we are talking about. From our notes, we will have this section where we are asked to shade specific sections. So what we're going to do is we're going to first set up a general method for labeling these objects. So first off, we want to make sure that we label these. The rectangle is U. The top left circle is going to be our A, the top right circle is going to be B, and our bottom circle is going to be C. And we just want to do that so that we are consistent in how we're representing these. Okay, so the first region we're going to shade in is going to represent U, the universal set, and that's just the entire rectangle, everything contained in the entire rectangle. So if we're talking about the universal set, we're talking about everything in the rectangle. Another point I want to make is that when our book labels these sections, they use Roman numerals, and the way that they label them is this section is 1, this section is 2, this section is 3, this section is 4, which in Roman numerals is IV or 1 before 5. This section here is 5, which is a V. This section here is VI or 6, which stands for 1 after 5. And then this section here is 7, VII. And then this last section in the universal set that's not contained in A, B, or C is 8, which is VIII or 3 after 5. Okay, so we'll see a lot of Roman numerals. I wanted to make sure you knew what they were talking about. But when we're asked to shade the universal set, that is everything contained within the rectangle. Let's take a look at these examples. I'm going to start with the 4 on the left-hand side. So let's zoom those in. Again, we're going to label these diagrams. Actually, I think I can get all 6 and then get the last 2 next. I'm going to label these diagrams consistently. And let's start shading. So when I'm looking at a set A, and I want to shade everything that's in that set, that's going to be everything contained in the circle labeled A. So if I label them with my Roman numerals, that's going to be 1, 2, 3 is not included, but I'll label it 4, 5, 6 is not included, VI, VII, VIII for 8. So those are the sections that are included when we have the set of A. Now let's shade set C. Again, that's just going to be everything that's contained in the circle labeled C. So we do have some of those overlapping sections, including 4, 5, 6, and 7 as our labeled regions. Let's do A complement next. A complement is everything in the universal set that is not in A. So that's pretty much everything in the box except the circle that is A. So let's shade that. I can get this part of B that's not part of A. That is shading A complement. Same thing if I'm going to do C complement. That's everything except for the circle that contains C, the set C. Okay, so the overlapping with C doesn't get included, but everything else does. And then let's look at these 2 over here. Number 4, A intersect B. That is the set that is both in A, or the set of elements that are both in A and in B. And then A minus C is A subtract all the elements that are in C. So that means that the overlap between A and C is not included, but everything else in A is. So that's that right there. So just labeling all those regions, you can see which ones are shaded when we look at each of these sets. So we have set A, set C. Number 4 has the intersection of A and B, the complement of A for number 6, the complement of C for number 7, and A minus C for number 8. Let's take a look at the last two. So for number 5, we have the union of A and B. Remember, the union, we count it if the element is in A, and we count it if the element is in B. So it's our or statement, so both are included. So I'm going to shade the union of A and B would be these. Okay. And then lastly, we have C minus A. So that's everything in C that is not in A. So that's this little kind of half, well, a little bit more than half moon. Okay, so those are our shaded sections for these situations. Now you could also do like B minus A and A minus B. You could also look at the intersections and unions between B and C. And there's a lot of things, and C and A, so there's a lot of combinations you can do for that, but you get the gist of what the relationships are in here. The next thing I want to point out is that we're dealing with 3 sets, so it's possible to be dealing with multiple unions and intersections. So for example, you could have A union B intersect C. Okay, so please remember our order of operations. You need to do your parentheses first. So we're first going to do B intersects C. B intersects C, I'm going to shade in purple. It's all the elements that are both in B and in C. Okay, then we're going to union that with A. So that's going to be everything in A plus this intersection. It almost looks like one of those cartoony like quote things. So the intersection would be every element that's included in this shaded section. So being able to shade your sections and create these diagrams could help you do a lot of the homework problems. For number 10, we're asked to shade the region that includes A intersect B intersect C. There are no parentheses, and so what we're going to start with is we're going to start in order from left to right. We're going to first do A intersect B, which is everything that's contained in A and in B. So that's that overlapping area. And then with that, we're going to include what's intersected with C. So I'm going to actually end up the final result in red. So A intersect B is shaded in gray. Now we're intersecting that with C. So we can only include now whatever is in A intersect B, but also in C. And so that gives us this very small region of all 3 areas. Now, when we think back to how we keep labeling this with Roman numerals, that region is that 5 region. So if they ask you to write which region it is, that's region 5, which would be written with a V. For number 11, when we have A union B union C, again, there are no parentheses, so we're just going to go from left to right. And we're going to say, okay, A union B, that's everything that's included in both A and B. And then we union that with C, so that's everything included in A or B or C. So my final result, I'm going to shade in red. So this is the shading when we have the union of all 3 sets. Okay, so intersection of all 3 sets, is that little area. Union of all three sets is all three of the circles. Now we're going to consider A complement intersected with B, the union of B and C. Okay? And we got to think about what are we going to perform first. What we're going to perform first, following our order of operations, is actually getting our parentheses done first. So we're going to do that union of B and C, and I'm going to shade that in red. The union of B and C is everything that's in set B and C. So B or C if you want to keep our ors and ands consistent. So if it's in B, it counts, or if it's in C, it counts. Okay? So that is our union of B or C. Okay? Now, A complement is everything that is not in set A. So I'm going to lightly shade that in gray, like a light gray. So A complement is everything that is not in A. So we get parts of B and C in that. Okay, so that's A complement shaded in gray. So the intersection of A complement with the union of B and C is everything that it has to be in both of them to count. So I'm going to take blue and outline what has both the red and the gray shading. It has to have both in order to count for the intersection. So that shaded region shows us the intersection of A complement with the union of B and C. Okay. Now we're going to consider how to shade the union of A with the set difference of B minus C. Okay. So again, we have our parentheses that I'm going to address first. And I'm going to shade B minus C. So B minus C is every element in B that is not also in C. So that's that little half moon right there that I'm shading in red. So this right here represents B minus C. Now we're going to union that with set A. So remember, for union, we count an element if it's in either A or the other piece of it. So I'm going to shade that in purple. So that's going to be everything in A plus everything that we shaded red. And so I'm going to shade that entire thing. And that is our region shaded in purple. The last part of this shading section is going to use deductive reasoning, because if we want to prove a statement true, we have to use deductive reasoning. Remember that deductive reasoning requires that we start with a general case and move to a specific. Okay, the general case, whenever we're dealing with algebra, means we have variables. Okay, so then we will use the Venn diagrams to model any set in order to prove statement true. So Venn diagrams are going to allow us to use deductive reasoning to prove some statements are true. So, yay, Venn diagrams. We like proving things true. So, we will have a hypothesis. Our hypothesis is C minus A equivalent to or equal to A complement minus C complement. Okay, remember, in order for two sets to be equal, they have to have the same elements in both sets. To prove this in general, we have to show through Venn diagrams that when I shade in C minus A, I get the same shading in that I would get when I do A complement minus C complement. If the same regions are shaded, or if the sets contain the same elements, then those two sets, or these two statements, are equal, and these two sets are equal. So let's start off by looking at C minus A. Now notice I'm only dealing with 2 sets, but I included 3 sets because that's the section that we're looking at, and we can still show the same consequences, conclusions based on using 3 sets even when we're only addressing 2 sets. So let's first look here, and we're going to do C minus A. So C minus A, remember, is everything in set C minus whatever's in A. So I'm going to shade this kind of crescent moon area right here. So this gray shaded region represents C minus A. Okay? Now, on the right-hand side, I'm going to actually do this in pieces so that I can better see what is happening. First, looking at A complement, remember that A complement is everything in the universal set that is not in A. So that's shading the, that's the eraser. That's shading this whole rectangle for everything except what's in A. And then C complement is everything in the universal set except for everything in C. So it's the same idea. And so by doing this, we can think of this as regions. Which regions did I start with that I'm supposed to take away? So when I'm addressing A complement minus C complement, okay, A, B, C, and this is the universal set. In A complement, I have the universal set, and I'm supposed to take away the universal set. This is what VII. So for A complement, I have the universal set. In C complement, I have the universal set, so I'm supposed to take away this universal set so I don't shade the outside in the rectangle. In A, nothing is in A is shaded, so nothing in A is going to be shaded for here. So region 1 and region 2 down here will remain unshaded. Here region 3 is shaded, but we need to take away region 3, so this is going to be unshaded, region 3. Here region 4 and region 5 are unshaded, and they're unshaded here, so we're taking away nothing from nothing. Here region 6 is shaded, but we're not taking it away, so it remains shaded. And here region 7 is shaded, but we're not taking it away because it's not shaded here. So therefore, this region is also shaded. Okay, now my circles are tiny, so you can't see, but these, let me draw this a little bit better. What we just ended up with was region 6 and 7 shaded, which are the same 2 regions that were shaded here. So based on this, we started with a general case. These represent any 3 sets in a universal set. We didn't say specific numbers that were in them. We just said, or values or elements that were in them. We just said, here's a general set A, B, and C. Here's a general set A, B, and C. Let me find C minus A. Let me find A complement minus C complement. And when we shade the same region on both, and we show that the elements of region 6 and 7 are the same elements in region 6 and 7 over here, we can definitively say with deductive reasoning that C minus A equals A complement minus C complement. Okay, a little challenge to try on your own. Is this true? A minus C complement, is that equal to A complement minus C complement? And you can do this all day. You could do unions, you can do intersections, you can see what happens, and we're going to do a few more in this chapter, in this section. The last part of the shading part of the notes, there's a couple of things that I'm asking that you try on your own. Okay, try those on your own, but then I will post answers in Blackboard. So you can check your answers after you've tried it on your own, or you can post them to the discussion board and discuss it with your classmates. Okay, but we're going to see hopefully a pattern and a law happen from the part that you try on your own. So it's really important that you do the shading on your own, figure out if these 2 or 3 statements are true, and then determine what's called De Morgan's laws. Okay, so try that on your own. I will post the solutions for you in Blackboard, and ask me questions if you have any. Thank you.